Alright, welcome to chemistry class notes. So today I'm going to be looking at some chemistry waec questions. Of course, for chemistry students writing waec theory questions, that should be next month. So this is just some past questions on atomic structure, a little of isotope, then periodic table. So without wasting much time, let's look at the first question. What are nucleons? When talking about nucleons, nucleons are protons and neutrons in the nucleus of an atom. So that's nucleons. Nucleons is made up of proton and a neutron. They are collectively called nucleons. So you can put it like this: nucleons are protons and neutrons in the nucleus of an atom. That means proton and neutron. So they are proton and neutron in the nucleus of an atom. So let's look at the second question. Consider the following atoms: X, which the mass number here is arrow, atomic number T, S, and T. State the phenomena exhibited by the two atoms. Of course, this is isotope. Known as isotope are existence of two or more atoms of the same element. Remember, X and X has to be the same element. They have the same atomic number and different mass number. So that is isotope. Remember, the element must be the same element, X, not XY. That is not isotope. So isotope is the existence of two or more atoms of the same element with the same atomic number and different mass number. So the phenomenon exhibited by the two atoms is isotope. Then the next question: if T is 17, write the electronic configuration of X. If T is 17, so the atomic number is 17, that is 17 is chlorine. So we're going to write the atomic number of chlorine because chlorine is 17. So we start by this. Okay, so this 1s2, 2s2, 2p6, 3s2, 3p5. This 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Remember, the s orbital can take a maximum of 2 electrons. P can take a maximum of 6. Then, so at the end of the day, you get 17. So this is the electron configuration of T, which is chlorine. Then the next question: what accounts for the difference in mass number of X? The answer is this: they have different number of neutrons. That accounts for the difference because they have different number of neutrons. So that's the answer. That's why that accounts for the difference that's what accounts for the difference in the mass number. So you can say have different number of neutrons. Alright. Then the next one, state one similarity between them. Similarity. They have the same atomic number. You can say they have the same number of protons. But let's just stick with they have the same atomic number, as you can see. Okay. So this is number one question. So go to number two. Remember, this one was 2016 chemistry past waec question. Next question. Copy and complete the following table. You have this element here, W2 plus, X2 minus, YZ. So you have to fill all these empty spaces. So from here, let's do with this first one. This W2 plus. We were given the number of neutrons as 12 and the mass number as 24. So we need to fill number of electrons and protons. Let's start with let's start with protons. So we know that neutrons plus protons equals to mass number, right? So to get the protons, we subtract neutrons from the mass number. And when we do that, we are going to get the number of protons to be 12. 24 minus 12, you get 12. So the number of neutrons is 12. Then for the number of electrons, you know this is not a neutral atom. So the electrons is not going to be the same thing as the protons, right? If it's a neutral atom, I would have said the number of electrons will also be 12. But since it's not a neutral atom, and we're given 2 plus, this 2 plus meaning it has lost 2 electrons. So you subtract this 2 from 12 to get the number of electrons. Suppose it was just 2, no charge, then automatically the number of electrons would have been 12. But since it's plus 2, that means you have to subtract. If it's minus, then you have to add. But in this case, it's plus 2. That means you subtract 2 away from 12. 12 minus 2 is 10. Next question. Okay, next side. So this one, we're given that's 8 protons and mass number of 16. We have to look for number of electrons and number of neutrons. So to get the number of electrons, just like we did here, since we know the number of protons to be 8, number of electrons would be, since it's 2 minus, now we are not adding. This one it has lost, here it has gained. So we have to add 2 to 8. 2 plus 8 is 10. Then number of neutrons, like we did here, protons plus neutron is equal to the mass number. And so to get the neutron, you subtract 8 from 16. So 16 minus 8, you also get 8. Then the next one, okay, these two are neutral atoms. Neutral meaning they don't have any charges. So number of electrons is 13, meaning the number of protons will also be 13. Then in order to get the number of neutrons, you subtract 13 from 27, giving you 14. Then number of electrons is 11, protons will also be 11. In order to get the mass number, you add number of neutrons plus proton, will give you 23. So let's look at this other question. What is the common name given to group 7 elements? Because group 7 elements are called halogens. There are some important groups in the periodic table that, they once in a while, they like asking questions from, like group 1 alkaline metals, group 2 alkaline earth metals, then we have transition metals, we have halogens, which is group 7, then group 8 inert elements. All these groups, once in a while, they like asking questions among those groups. So take note. So the name that is the common name given to group 7 elements is called halogens. Halogens, I'll write it here. Halogens. Then name the hydrides of the first 2 elements in group 7. When you say hydrides, hydrogen combines with those non-metals. We say hydrides. So the first 2 elements there, we have fluorine, chlorine, bromine, and iodine. So the first 2 elements is fluorine and chlorine. So hydrogen fluoride, hydrogen chloride. So for this question, name 2 hydrides of the first 2 elements, hydrogen fluoride and hydrogen chloride. Then state 3 chemical properties of group 7 elements. That is halogens. Well, there are different properties. Well, one of them is that they are strong oxidizing agents. Another one is they are, electronegative elements. They react with hydrogen to form, hydrogen halide. They react with metals to form metal halides. So the other properties, you can also look it through. And this one is 2013 chemistry waec past question. So look at this one. Atoms of 4 non-metallic elements in the same group of the periodic table are arranged in order of increasing atomic radius as R less than T less than W less than X. Which of the elements would readily lose electron from the outermost shell, is most electronegative, would take the space from aqueous solution, is at the top of the group. So first of all, atoms of 4 non-metallic elements in the periodic table are arranged in order of increasing atomic number R, T, W, Z, X. This fits halogens again. This fits halogens, right? Atomic radius. In the periodic table, atomic radius, decreases from left to right and increases down the group. And so from here, it's telling you that this arrow is less than T. T is less than W, and W is less than X, meaning arrow is the smallest, X is the largest. So arrow will fit fluorine, T will fit chlorine, W bromine, then iodine, right? Knowing that atomic radius increases from left to right and decreases down the group. So this arrow would be fluorine, chlorine, bromine, and iodine. Arrow is the smallest and X is the largest. Going down the group, the atomic size increases because the number of shares also increases. But on top of the group, the same along the period, the same shares are freed, thereby the attraction for the atom selection for the nucleus increases. That will decrease the atomic radius or the size. So which of the elements would readily lose electrons from the atomos share? The element that will readily lose electrons from the atomos share should be the one that has large atomic radius. Why? Because since it is large, there will be less effect for the atomos electron on the nucleus compared to if it's small. The effect will be more, and so the answer would be Ox, because this one has the largest size. So the next question is the most electronegative. Of course, when you say most electronegative, it has to be the one at the top. Is willing to receive or get electrons. It's not willing to give out. So that would be fluorine. That is arrow, which is the most reactive and the most electronegative. So I'll say arrow. Would T displace from aqueous solution? Remember, T is chlorine. In the periodic table, the reactivity, remember, reactivity decreases down. This is the most reactive, followed by this. The one that is most reactive can displace the one that is less reactive. And so T, which is chlorine, cannot displace fluorine because fluorine is more reactive than chlorine. But T can displace this and this. Remember, reactivity decreases down that group. So T, which is chlorine, can displace bromine, which is W, and iodine, which is X. So the answer would be W and X. Then the last one, which one is at the top of the group? Of course, you can see that the answer is arrow. Remember, this is 2009 past question. The following table shows the electronic configuration of Y and Z. This is Y, this is Z. So Y is, let's say, 5, 6, 7, 8, 9. So you can see that Y, if you count it, 9 has 9 electrons. That is fluorine. Then Z, 6, 7, 8, 9, 10, 11. So Z is 11 is sodium. So in your mind, Y is fluorine, then Z is sodium. Name the group to which Y belongs. Because since you know that Y is fluorine, that means Y belongs to group 7. You know that one. But if maybe you might have forgotten, so this is a way to know it. If you look at this atomic electron configuration, since this one is second share, they are both, the second share, 2, 2, second share. This is the first share, this is second share. So in this second share, what you do is you add the numbers on top, 5 and this 2, to get the group number. Then if you are asked for period, the first number here is the period 2, group 5, group 7, because of this one in the same shell. So the answer is group 7. I'll do this, group 7. Then period to which Z belongs. Remember, you look at the last orbital. So this one, period, this period 2, period 3. Period 3, group 7. Yeah, the group is group 1. Yeah, the group is group 7. Why is this one group 1? This is another energy level, right? Because these two are the same, that's why I have to add this and this. But here there's 3 and there's 2. You can't add this and this. You just go straight. Group 1, period 3. So what is the number of protons present in Z? Number of protons present in Z. First of all, Z has 11 electrons. For a neutral atom, the number of protons is the same thing as the number of electrons, which is also the atomic number. So to know the number of protons, you add these values. So at the end of the day, you get 11. How many unpaired electrons are in Y? Why? You know that P has 3 orbitals, right? We'll do something like this. So the first one can take a maximum of 2, but let's flip like 1, 2, 3, 4, 5, right? This for 5, P5, 1, 2, 3, 4, 5. Remember, you fill the first shell single first, 1, 2, 3, 4, 5. So at the end of the day, you are left with 1 unpaired. So it has 1 unpaired. Then the next question, write the formula of the compound formed between Y and Z. The formula of the compound formed between Y and Z. Remember, Y is fluorine and Z is sodium, and they are both, they have both a valency of 1, and so what they form will be ZY, which is sodium fluoride, NaF. So Na is Z, F is Y, so it's ZY. So next question. Copy and complete the table below as appropriate. We have to fill these boxes. So yeah, hydrogen, number of protons, number of electrons, number of neutrons. So to get the number of neutrons, you subtract this from this. So 1 minus 1 will be 0. Then yeah, aluminium, 3 plus. So the number of neutrons, number of protons. So the number of protons is 13. Then number of neutrons, you have to subtract 13 from 27, and when you do that, you get 14. Then the number of electrons, since this one it has lost 3 electrons, so you subtract 3 from 13, you get 10. Then the next one, number of electrons, okay, number of protons for this one, oxygen, will be 8. The number of electrons, 2 minus, you have to add 2 to 8, you get 10. So this one was 2003 past question. The process is the same. So let's look at this one. Consider the following table. Atomic number and the mass number. First of all, you have to know each of the elements to make it easier, right? So we know that J, atomic number of 9, that is fluorine. Q, atomic number 13, 13 is aluminium. Arrow, atomic number of 16, 16 would be sulfur. X, atomic number of 19, 19 would be potassium. Then Y, 24, Y should be chromium. So having this in mind, let's answer the questions. Which of the element is a halogen? Of course, we have been doing halogen since. The one that is halogen would be J, which is fluorine. I'm going to put J here. This is halogen. Then it's most likely attracted by a magnet. Of all these elements, this guy is a transition metal. And to a large extent, they are more, magnetic than other elements in the periodic table. So the answer that is the one that is most likely attracted by a magnet will be chromium, and that is why. Belongs to group 1. Belongs to group 1. The one that belongs to group 1 would be potassium. X. Potassium belongs to group 1 of the periodic table. Guys, I'm going to put X. Then would readily form an ion with a double negative charge. So that would be sulfur. Sulfur, arrow 16. Sulfur can form an ion with negative charge. Then what type of bond exists between J and X when they combine? J and X. Remember, J is fluorine, X is potassium, right? So the type of bond that will be formed, J and X, J and X, J and X. Okay, J is fluorine, X is potassium, and so the answer would be X. Type of bond that will be formed would be ionic or electrovalent, because it involves metal and a non-metal. This is a metal, X is a metal, J is a non-metal. So the kind of bond they form will be ionic or electrovalent. How many neutrons are there in Q? Q is aluminium. To get the number of neutrons, you subtract this atomic number from 27. So you get 14 neutrons. So write the formula of the compound formed when arrow combines with X. Arrow is sulfur, then X is potassium, and you know that potassium has a valency of 1, S has a valency of 2, although S also has other valencies, right? 2, 4, 6, but in this case it uses valency of 2. for this combination, right? So remember, arrow is sulfur and X is potassium. So it's going to be something like this: potassium, sulfur. This has valency of 2, this has valency of 1. So do something like this. And you are getting K2S. But in this case, when arrow combines with X, X is K, arrow is S. So it's going to be S2 arrow, right? S2 arrow, because S is K, arrow is S. So this is the answer. State the element which exists as diatomic molecules. Of course, the element that exists as diatomic molecules, of course, that would be halogens, which is fluorine. J is fluorine, so J exists as diatomic molecule. They are halogens. Then the last one, select the elements which belong to the D block of the periodic table, because those are transition metals. From 20 to 30. From 20 above 20, right? That is from 21 to 30. They have their valence selection is in the D share. So anything from 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. The D block belong to the D block. So the answer would be Y. Y is chromium. Chromium has atomic number of 24. So that's the end of this video. Because I'm going to put out some more videos on maybe periodic table and some other topics, just for chemistry students writing waec. I think in next month, just for you to revise. You still have to do your own part, read up more questions, go through more past questions, and you'll be okay. If you enjoyed this video, you can leave a like and subscribe. Thank you.